round. I'm given the sales M and I'm asked to find the price P. And you know how to do that. So now M is 168 equals minus 12P plus 408. And now you can rearrange. 12P is 408 minus 168 is 400 minus 160, which is 300 minus 60, which is wait. Yeah, 240. Then I divide by 12, which is 240 divided by 12 is 20. So the price I should charge is $20. At a price of $20, I would sell 168 cakes. So then I know I should make 168 cakes. I charge $20 per cake. Yeah? Okay. Next problem. Number 4, who wants to read it? This is pretty easy, I think, right? The wonderful mobile phone company charges $70 per month and calls cost 50 cents per minute, $0.5 per minute. If I use my phone for X minutes in a month, write down an expression for the total cost in terms of X. So the total cost in terms of X, that tells me, this is cost is a function of X. In terms of X means this is a function of X. I should be careful. It doesn't always mean that, but usually. C total cost in terms of X means I want C equals an expression in X. The expression may or may not be a function, but it's an expression that has X's in it. So C equals something with X's in it. So imagine you have I realize this is not exactly how it works in Malawi for phones. What is is there something here that you have to pay a monthly fee and then, or like do you have a bank account? Anybody? Yeah? Is there a standard monthly fee you have to pay every month for your bank account? Okay. Anyway, in many countries, the way it works with your mobile phone, instead of you buy units or minutes prepaid, is for the phone company, for my phone to be connected to their network, I have to pay them an amount every month. Even if I don't use my phone, just to be connected to their network, I have to pay a basic amount. That's what this is. There's a basic fee. So even with 0 minutes of calling, I never even turn on my phone, just to be registered with them, costs me what? $70 a month. Then if I make a call, for every minute of a call, it costs me this. So now, if I use my phone for X minutes in a month, what is the expression for my total cost? So my total cost per month is the $70, which I have to pay anyway, plus how many minutes I call times the price, 0.5 per minute. So my expression would be 70 plus 0.50x. And that's all. You're just asked to write down the expression. You don't have to calculate anything. You're just taking the words and putting them into a math expression. So now this is the same information as all this. And that's why math symbols are powerful. It's just like another language. This is saying the same thing as all these words, except it doesn't have the name of the company. Now, repeat part A, so do the same thing. For the fantastic mobile phone company, this one charges $20 per month. That's much better. Instead of 70, only 20. But for every minute you call, it costs more. Now it costs $1 per minute instead of half a dollar per minute. So the expression is C equals 20 plus 1 times X. And then last, plot both graphs on the same axes, and hence find the call time per month, which gives the same total cost for these two companies. So we have to plot. So I think one of the things this exam showed is that you know how to do algebra, but you're not comfortable so much with graphing. What will we put on the x-axis, and what are we going to put on the vertical axis, the horizontal and vertical axis? What are our two variables in this problem? The two variables are, one of them is x, how many minutes I talk. What depends on x? The cost. So which one goes on the horizontal axis? Which one goes on the vertical axis? What? Vertical cost. And then horizontal x, the number of minutes. Now it says plot both graphs on the same axes. Do we know what that means, on the same axes? On the same plane. So I don't make one here and one here and make one line and another line. No. What I do is I have a set of axes, and I'm going to put both lines on the same graph, on the same axes. So one of them is 70 plus 0.5x. So we need some 7, 6, 5, 4, 3, 2, 1. And then minutes, I don't know, 10, 20, 30, 40, 50, 60, 70, 80, 90, 20, 100. This is 50, this is 20, 40, 60, 80. So this is in dollars, and this is in minutes. Okay, so 70 plus 0.5x. Now you should know how to graph, right? So who wants to come and graph? You can choose any color you like, black, blue, or red. Somebody can do this one, and somebody can do this one. Let me maybe write them here so they're easier to remember. So we have C is 70 plus 0.5x, and C is 20 plus x. My twos look terrible. There we go. So you can help him out also. So start maybe, usually it's easier to find where is the intercept. Which one do you want to do first? This one or this one? That one, okay. What is the intercept for this one?
Intercept is 0.5x. Y intercept.
Do we agree? Oh, why not? You were quick to say no. Why not? What do you think is the intercept?
Intercept. No, yeah. Intercept. Y intercept. The intercept, yeah. Between this and this, which here? The red is slow.
So slope always multiplies the independent variable. The slope multiplies x. So don't memorize that slope is on the left and right. Left and right, in math, left and right means nothing. I can write like this, I can write 0.5x plus 70 is the same thing. So don't memorize left and right. Left and right doesn't matter. You have to, yeah? The slope is what multiplies x. The intercept is the constant by itself. Where is 70? Mm-hmm. You can talk to your friends while you Okay, you don't have to. You don't have to.
Yeah, so according to our graph here, this is intercept, y intercept, presented, and this is slope. So, means though we are not indicating this is the 10, but what I know is this is 10, 20, 50. So it's 0.5. I mean, I'm assuming that it is here. So you can measure. So then for this equation, this just and x. So a x vale, then you can say here. Assuming. So how can we go around? Right. I think because both have different that means so this seed should be like yeah.
You're drawing the second line? What's the intercept of that line?
20. 20.
And what is the slope?
So it's 1.
Mm-hmm. This is a class effort. I'm going to come and look, and it's the whole class. It's not just him. So everybody has to agree.
Alright. If this is zero, okay, we are done.
So what did we find as the answer? So the purpose of this was to find for what number of minutes total is the cost the same. In other words, where do the lines cross? Cross. When the lines cross, it means at the point where they cross, they have the same x and y, correct? So that would mean they have, for that number of minutes, they have the same cost. So where do the two lines cross? That's actually the question. Not cross the y-axis, cross each other, right? The two lines. Why is there a line going down? Are the slopes negative? Guys, how did you allow a negative slope? Thank you, Justin, for being the graphic person. 20 plus x. Can someone explain what you were thinking? It's crossing at 10, but we said the intercept is 20, and then it's going down. How did we arrive at this? Huh? This point? What is this point?
That's the student.
It's one.
C is equal to 2 That's one. Yes, the slope.
But then you left with y equals 0. Is it true? If x equals 1, what is c?
If x is equal to 1, c is 20. If c is 21.
So 1, 21, and then 20. So the line is you have to think of both coordinates. Yeah? Now, this probably isn't quite accurate, actually, so I'm going to take it off. The way I would draw it is I would say 20. If I only add 1, it's so close that it's hard to get it just right. It would be easier if I have a point somewhere here. So let me say, okay, I can go up to 80. So let me say I want to get to 60. For C to equal 60, what would be X? If C equals 60, what is X?
X is
40. Okay, so here's 40. 40, 60, there. Okay, that's easier to draw. Then I can do something similar. 70 plus, let me get to 80. For C to equal 80, what is X?
Oh, that's a question.
Mm-hmm. So X equals what? It's too light to see, no? 0.5 is the same as a half, right? Twenty. 20 times 0.5 is 10. 0.5 is half, right? So 20 times half is 10, plus 70 is 80. Okay, so we need X equals 20, C equals 80. So here's 20, and here's 80. We have 70 as the intercept, so now this line goes like this. And now I should have made my graph lower, but we will find that they cross somewhere here. And then where they cross, we could drop a line, and we would find, if you did it carefully, you should find 100. So what does it mean when two lines cross? So I'm going to take this and put it over here. Yeah? This is a blow-up. I have the black line like this, and I have the red line like that. At this point, the X and C, X1, C1 is the same as X2, C2. If this is 1 and 1, 1, 2, 2. I shouldn't say 2. But XC1 equals XC2, which means for the same number of minutes, at this point where the lines cross, they have the same cost. Anywhere else, if X is here, then the cost, this one is less than the cost of that one, right? That's what it means. If I'm here in X, then this cost is less than that cost. But where the two lines cross, the costs are the same. So now the question is, for how many minutes, at how many minutes a month are the two plans, remember there's the two mobile phone companies. One charges you $70, but only $0.5 a minute. This one charges you $20 a month, but $1 a minute. And so as you add minutes, they increase, but this one increases faster. It has a higher slope, yeah? It's going up faster. And at some point, the red is going to get bigger than the black. But before that, they're going to cross. They're going to be equal. And the question is, what is the value of x at this point? And you would find that the answer should be around 100 minutes. Okay. Okay. So plot both graphs. Have we answered the question? It's always important to go back. When you think you're finished, go back, read the question again, and make sure you have answered everything. And I guarantee you that you will find sometime, oh, I forgot, there was this other, it also asked about this, and I forgot about it. Because I was so busy calculating part A, I forgot to do part 2. Right? So it plot both graphs on the same axes, and hence find the call. So we had done this, right? And then you thought you were done. And I said, there's another part to the question. Find the call time per month, which means find x, which gives the same total cost for these two companies. Okay, same total cost means where the lines cross. So you would plot, you would find where they cross, you would find the value of x, and you would give the answer. The cost for the two companies is the same when the call time is 100 minutes. Usually, actually, the way I was taught, when you're asked a question like this, it's not enough to say x equals 100 minutes. You have to write a sentence. This one asked in a sentence, you have to answer in a sentence. The total cost for the two companies is the same when the call time per month is 100 minutes. Full stop. You write a sentence. You answer the question.
So what the scale is different? Scale of the graph, like in 100, why those different scales is any of it?
Then you'll have to change your graph or draw it again until you find it. Of course, usually you might just use algebra and solve it algebraically. It would be easy. You don't need the space. Fine. So the next one, as accurately as possible, which means be careful, try to get the measurements right, the lines straight. Draw the graph for each of the following functions. These are two lines. I don't think we need to go through it again. Compute the slope and the intercept for each of the following graphs. Then write the equation of the line. So again, you have to read every part of the question and make sure you answer every part of the question. It's not enough to just compute the slope and the intercept and say, I'm finished. You have not finished. You have to do that and then write the equation of the line. So I was asked by the invigilator, one of you asked, is this the zero? Where is the zero, the origin? And the origin is where the lines cross. But if you put 0 here, then it's not very helpful. So they write the 0 here, but this is 0. This is 2.5, or minus 2.5, 2.5, minus 2.5, 2.5. So you can see 0.5, 1, 1.5, 2, 2.5. 0.5, 1, 1.5, 2, 2.5. Minus 0.5, minus 1, minus 1.5, minus 2, minus 2.5. And the same going down. So then, all you want to do is, let's see if I make it a little bigger, is you want to find some points where it crosses at where you can get the coordinates nicely. So here it looks like maybe this point, which is 0.5 and 1.5, and the origin. And now I can calculate. So what's the intercept? That's easy, it goes through 0. So the intercept is 0. I grew up writing it B, sorry, so I know you write C, I write B. then what is the slope? Well, it went up 1.5 from 0. I didn't write 0, 0, but you know this is 0, 0. So to go up 1.5 from 0, that's the delta y. The delta x is 0.5. So delta y divided by delta x will be 1.5 minus 0 divided by 0.5 minus 0, which is 1.5 divided by 0.5, which is 3. And then I can write the equation. Y equals mx plus b. M is 3, so 3x. B is 0, so I don't write anything. Y equals 3x. That's my equation. Now, the other ones, they're all the same. The line is in different places. So here, that looks like it crosses on the grid. And here, or here, whichever one you like. And then you do the same thing. And you find b, m. B, you can just read it. What is the intercept? Minus 1. Done. And then you write the equation of the line. The one that was maybe a little... it wasn't tricky, but the numbers were not as easy to find. You had to now estimate. So you can use this point as the intercept. You could have used here and here. They go through the axis, through the grid. But you could use this, and then it's sort of approximate. You get an intercept, calculate the slope, and then you write down the equation of the line. So the slope is a fifth, so it's x over 5 plus the intercept 1.3. So you see, you can do all of this. None of this is tricky. But if you haven't practiced enough, you look at it and you freeze, or you start thinking, oh, it's a problem like this, but actually no, it's that, and it's not complicated. But if you haven't practiced enough, then it either it takes too long or you go the wrong direction. Okay, this one, I should, okay. Now, a few of you, again, did not read. There was a similar problem in the assignment. And in the assignment it said, determine whether this is a function. If it is, then give the domain and range and blah, 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 blah. Remember? If it is a function, then do all of this. But what does this say? It says, for each of the graphs below, determine the following. It doesn't say, if it's a function, determine the following. It says, for each of them, determine the following. So just because you saw one problem somewhere that was 1, you have to read carefully and say, this is a little bit different than what I've seen before. You have to read. Every word matters. Every word matters. So, domain here, domain, remember, is all the values of x for which there is a value of y. Yeah? In this case, it's the whole x-axis, from minus infinity to infinity. All the way that way and all the way this way. The range is what are the values of y that are used. And here, it doesn't go below minus 0.2, and it doesn't go above 2. So the range is minus 2 to 2. This is how you would write it normally. If you wrote it in words, that was also fine. What are the x and y intercepts? I wrote it in a shorthand. I think some of you wrote x is minus 2.5, minus 1.5, minus 0.5, 0.5, plus 1.5, plus, or 0.5, 1.5, 2.5, and so on. So this is n, if n is an integer, minus 1, minus 2, minus 3, 0, 1, 2, 3, plus or minus a half, you would get the same thing forever. And the y-intercept is 2. Is there a symmetry about any axis? This side looks like that side, right? So there's a symmetry around the y-axis. If you put a mirror, this would look like this. So it has a y-axis symmetry. If you go the x-axis, it's not a mirror. This doesn't have anything here. And across the origin, if I go from here to there, also there's nothing. So there's no symmetry about the origin. Only the y-axis. Is the graph even, odd, or neither? So even and odd means if I make the x minus x, basically if I flip it around, does it look the same or does it look inverted or neither? In this case, if I flip the two sides, then it looks the same. So it's even. The definition of even, I don't know, we didn't cover this in class, but it was in the book, and I assume that you have learned this before. The definition of an even function is that f of x f of minus x equals f of x. So if I have f of 1 should be the same as f of minus 1. So I can check. This is 1. F of 1 is minus 2. What is f of minus 1? Also minus 2. So f of minus x equals f, and it's true everywhere, which means it's a mirror image. So an even function has a y-axis symmetry. An odd function is almost the same, but f of minus x equals minus f of x. Now what does this mean? We'll see an example of an odd function. Is it continuous? Yes. You don't have to lift your pencil, you can just draw. Is it a function? Yes, it passes the vertical line test. So those were all the correct answers. Let me jump to C because it's, well, let's do B first. So B looks the same, but now it's rotated. Is this a function? Clearly not. Doesn't pass the vertical line test. But does it have a domain? Yes. The x values go from minus 2 to 2. So notice it has the opposite of the first one. Now the domain is minus 2 to 2, and the range is, it can go all the way down forever and all the way up forever. So minus infinity to infinity. I think some people said like minus 3 to plus 3 because that's what you can see, and I accepted that. Even though in your mind you should think, when you see a graph that goes off and it follows a pattern, you imagine it goes forever. The x-intercept, this is the only place it crosses the x-axis, so x equals 2, and it crosses y. So notice, it's just the flip of this one. So instead of a y-axis symmetry, it's not symmetric like this, but now it's symmetric like this. If I take this half and I fold the piece of paper, the line will touch itself everywhere, right? It's symmetric. This is not even or odd. If I take, right, from this definition, if I have x equals 2, what is the function value at minus 2? Well, it's not even defined because it has many. In fact, even here it has many. But this is not equal to that. So it's not even and it's not odd either. It is continuous. You don't have to lift your pencil. And it's not a function. Here, I realize afterwards that the dashed lines are in the wrong place. They were supposed to be right on this line. But when it was printed, it got shifted a bit. So, I think I was lenient with that one. If you think I missed it, then you can ask me. But it doesn't matter for everything. It only matters for a few things. So what is the domain? The domain is all of the values of x, except where the dashed line is. Do you know what the dashed line represents? Why is there a dashed line? Anybody know? We haven't talked about it yet. I thought you learned all this in secondary. It's called an asymptote. I talked about this in class. Yeah, I did. An asymptote is if I have the function 1 over x. I remember I talked about this, right? This will go forever, but it will never touch the x-axis. If I do 1 plus 1 over x, then actually it will look like that's the x-axis, and this is y equals 1. And this function will get close and close and close, but it will never reach the dashed line. So the dashed line tells you the function will get close to me, but it will never touch me. Right? If it never touches me, that means there is no value there. So at this value of x, there is no value of y, which means this is not in the domain of this graph. There is no value of x there, or of y for that x. So the domain is from minus infinity to infinity, excluding the points where the dashed lines are, which was supposed to be here. But if someone said from infinity to infinity, I accepted it, even though technically it's not correct. The range is also minus infinity to infinity. This one is symmetric about the origin. If I take this point and I go to the origin and the other side, I find the same curve. If I'm here and I go across the origin, I find the same point. If I'm here and I go to the origin the same distance, I find in the same direction, I find I'm always touching the line. So that makes it symmetric about the origin. The intercepts for the y-axis, it only crosses once. For the x-axis, it crosses here, 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 and everywhere. It's not as easy to see, but this is an odd function. So now we can test our understanding, right? The odd function is that a function of minus x is the same as minus the function of x. So we're going to take it in two parts. We're going to look at this one and see if it equals this one. So if we choose x, let's choose x equals 0.5. Yeah? So if x is 0.5, what is minus x? It's minus 0.5. So we need the function at minus 0.5. So minus 0.5 is here. There's the function. It's minus 1. So the function of minus x, remember x, we're choosing x equals 0.5. Then the function of minus x is minus 1. Now, what is the function of x? So at 0.5, the function of x is 1. But now I need a minus sign in front. Minus the function of x. So the 1 is minus 1. Minus 1 equals minus 1. And if you look at it, you will see this is true everywhere. Therefore, this is an odd function. Odd basically means the visual way to be an odd function is if I flip this way, that's the minus x, then it's equal to flipping it this way. Right? Imagine if you take these two and you flip them, then you would have a line like this. And if you take this and you flip it like that, you would also have a line like this. The two would be the same. That makes it an odd function. What else? It's discontinuous because to draw this, I have to lift my pencil to keep going, and lift my pencil and keep going. I think some people said continuous, and I accepted it because it's continuous within the domain, technically, if you exclude the domain. But it's not continuous over the entire domain. So I didn't mark that. I accepted both answers. Is it a function? Yes, it is a function. It passes the vertical line test. And the last one, This one, I think, was straightforward. What's going on? Oh, I can make it bigger like that. Yeah. So the domain is everything. The range is -1 to 1. The y-intercept, it had two y-intercepts. This one and this one. You have to find both. The x-intercepts are here. It's symmetric about the origin. This is the same as that. This is the same as here. Not the same, but you will find a point there. There. So if you can go through the origin by the same distance and you always find that you're on the function, then you're symmetric about the origin. It's discontinuous. I think everybody saw that. You have to lift your pencil to keep going. Is it a function? No. But why? Why is it not a function? It's almost a function, but it's not. Why not? Does anybody see? So to not be a function, it means that somewhere, if I draw a line, I'm touching 2 points, at least 2 or more points. Then it's not a function. Is there anywhere that if I draw a vertical line, I'm touching 2 points or more? I'm touching that point, and then I'm touching this point. And the same here, and the same here, and the same here, and the same here. So here, it's only 1, that's okay. But here, there's 2 points. 1, 1, 1, 1, 1, 2. 1, 1, 1, 1, 2. For this to be a function, we would have to draw it like this. You remember asymptote is this dashed line. And the dashed line is not part of the curve, is not part of the function, but it tells you something about how the function behaves. So if we drew this, right? Now, this is a point, this is not. The open circle means there is no value here. Then my line only crosses 1 point. So this would be okay. Or the other way, this could be open and this could be closed. Or they could both be open. Then there's no value here, but that's okay. No value is fine. So this would be a function. But as soon as you have 2 filled points on the same line, then it's not a function. Almost done. Limits. So we had just started a little bit. The limit of a function, g of x, as x approaches a. Should I draw it or explain it? So we have to imagine we have a function, g of x. Here is a point A. So the limit of g of x as x approaches A is what? Is it the value of A? Is it this? No. So the limit is if I'm approaching A, what is the y value that I'm getting close to? It's this, right? This is the value of the limit. As my x, as I move closer and closer along the line, what am I getting close to? Even if this is an open circle, maybe the function has no value there, but I'm getting close to. So the answer is, it's not the value of a, right? That's easy to see. If this is my y-axis, then a is a negative number. This is negative x, but the function is positive. So clearly it can't be a. Is it the value of the function at a? Almost, but no, because if I have a function like this, remember? There's no value here, but there's a value here. But the limit is I'm getting close to this point. I'm not getting close to this point. So B is not correct. It's often, it happens to often be true, but this is not what it is. The end of the sequence of values of x as it approaches a, I forgot a few words there. So is it that as we come here, x is approaching a, what is the end of that sequence? Well, it's a again, and we already saw a is not the answer. So that leaves D. The end of the sequence of values. So a sequence, you remember we did those tables. If x is 0.1, 0.01, 0.001, 0.0001, right? As you get closer and closer, then what was the y? If this was 0.1, 0.01, 0.001, then this is a number, and these numbers are a sequence. Yeah? As the x gets closer and closer to a, in this case, a would be 0, we're getting closer to 0. So as x gets closer to 0, we're not going to reach 0, but we get closer, these values get closer to a number. And that is the limit. The end, this sequence of numbers, as x approaches a, these numbers approach something, which is they approach this. And so D is the right answer. We're probably out of time, huh? Yeah. We'll stop there, but the bonus question, quickly, I guess I'll just tell you. So this was a bonus question because we didn't cover one-sided limits yet, but it was in the chapter that I told you to read. So the limit of f of x when x is 10 equals 0. Well, if you approach 10, is it equal to 0? Yes. And then B, C, and D are all false. We can do it next time if you want. Or do you want to finish today? I should give you your exams now. So, BAC 003, this is Michael? Oh, I didn't write your marks on here. I wrote the marks on the problems, but I didn't write on the cover. But that's okay. I wrote it down in the computer, so I know what the grades are. But do you want me to write down what your grade is? BIA 001, Charles. BAC 006, Loveness. BAC 005 is Justin. James. If you want to come and ask me, I'll tell you what the total grade is. Linda. Ishmael. Do you want me to tell you your grades? I'll tell you, the grades range between 9% and 38 or 39% is the highest grade out of 100. The highest grade was like 38 or 39, I think. So I can send you by WhatsApp each of your grades if you want. Or I can tell you now. You want to know? Huh? Next time what? Justin, yours is 32%. 32. Loveness, 27. Ishmael? You want me to tell you? Just write it down? Oh. Can I borrow your pen?
What's up?
Today's 25th, right? Can you stop or is it stopped?